Welcome to the walkthrough of Assignment 3 in my CS253 class. The purpose of this assignment is to deepen your experience using Java's functional programming features and their integration with Java's completable features framework. In particular, in this assignment, you'll develop an app that uses Java's completable features framework in conjunction with Java's sequential streams framework to obtain, transform, and store images asynchronously in a pool of threads. Like the earlier assignments, the code you write here will have a GUI and will run as an Android app. Please use this GUI along with the unit tests outlined below to help debug and evaluate your solution. The following resources may be helpful in completing this assignment. Detailed overviews of Java's completable features framework are available in videos from one of my YouTube playlists. Naturally, we'll cover this material in class, which will be available in my YouTube CS253 playlist here. Good overviews of Java's completable features framework appear here and here. I highly recommend you get the book Modern Java in Action to learn more about Java's completable features framework. The image crawler app is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 3, however, you only need to be aware of the following folders. Image crawler crawlers, which contains the skeletons you need to fill in, as described below, and image crawler source test, which contains a set of unit tests that exercise the features you're implementing and are used to evaluate whether you've correctly satisfied this assignment's requirements. To compile this code, you need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app's minimum API is 31, so you need to select an emulator that uses API greater than or equal to 31. I recommend API 32. If you don't already have an Android emulator, you can create one by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do you fill in here tasks to provide a working solution. Do not change the overall structure of the skeleton. Just fill in the to-do tasks and do not delete the to-do tags. In particular, you need to finish implementing the following to-do tasks for this assignment in the image crawler crawlers folder. First, you'll need to complete the to-do tasks in completablefuturecrawler.java for various methods there to obtain, transform, and store images asynchronously. This class uses the Java completable features framework to perform an image crawl asynchronously, starting from a root URI. Depending on the parameters used to run the app, images from the HTML pages reachable from the root URI are either downloaded from a remote web server or read from the local file system, transformed locally, and the transformed results are then stored in the local file system on the Android device. You'll also need to complete the to-do tags in the student.kt file to set the type field to include just graduate or undergraduate, depending on which version of the assignment that you're implementing. The bulk of the code for the app is provided in the skeletons. In fact, a complete solution using Java 7 features is provided in the sequential loops crawler.java file. You'll therefore convert this Java 7-based class to the completable feature crawler class that uses Java completable features. Your solution should use no loops or if-else statements in the assignment, and instead use Java completable features methods and functional programming features. Likewise, there should be only one call to join and no calls to get. Your solution will be considered correct if it passes all the unit tests, is commented thoroughly, and addresses my review comments. Skeleton code for this assignment is available here in my GitHub repository. Now that you've set up your GitLab account, you can pull this skeleton code into your repository, read it carefully, and complete the to-do markers. The unit tests in the image crawler source test folder are provided to increase our collective confidence that your implementation is working as expected. Please use the Android Studio GUI to run the unit tests locally on your computer, as described here. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the unit tests to detect problems in your code. Assignment 3 is more complicated than the previous assignments, though it does not have a remote server component. In particular, the asynchronous nature of Java's completable features framework may take some time to get accustomed to. So please start the assignment soon and ask questions in class, office hours, and on the Piazza discussion forum. As usual, the app, image crawler skeletons, and unit tests are extensive, though you don't need to understand them all to complete your solution successfully. Now that we've walked through the specification for assignment 3, let's go ahead and take a look at the skeletons, which appear in the completable features crawler.java file. This implementation strategy uses Java's functional programming features, Java's completable features framework, and Java's sequential streams framework to perform an image crawl asynchronously, starting from a root URI. Images from an HTML page reachable from the root URI are downloaded from a remote web server or the local file system, and the results are stored locally in files on the Android device that can then be displayed to the user. Let's take a look at the fields involved here. There's really just one field. It's called M0, and you need to fill in the implementation here, replacing null with a solution that will store a completed future with the value of 0. And I'll talk a bit about where that gets used later. Let's now take a look at the main entry point into this particular implementation. It's the perform crawl method, which performs the web crawl. It's passed the URI that's being crawled at this particular level of the recursion, and it's also passed the current depth of the recursive processing. And it returns the number of images downloaded and stored at this level. So what you're going to do here is you're going to perform the crawl asynchronously by calling the crawl page async method, which we'll talk about here in a second. You'll wait until all the processing is done, and then you return the result. This is the only method in the entire Completable Futures crawler class that should call join. And there should be no calls to the get method on Completable Future at all. So this is where you put your solution, replacing 0 with the actual call. Now what you're going to end up calling here is the crawl page async method. And this is the method that asynchronously performs a web crawl by using Java's Completable Futures framework to download, transform, and store images on this page, and then also crawl any other hyperlinks accessible via this page. What we're passed in is the URL for where we're crawling at this point and the current depth of the recursive processing, and it returns a completable future to the number of images that were downloaded and stored at this level. So here's what you need to do. You need to create and use a Java sequential stream, which has a factor method that makes a one-element stream containing just the page URI. That should sound familiar because that was what you did in earlier assignments. You'll then use an intermediate operation to filter out the page URI if it exceeds max depth or it was already visited. You'll then use another intermediate operation to call the method crawl page helper, which will return the total number of processed images at this page URI. And then finally, you'll use a terminal operation to get the total number of processed images from the one-element stream. This is going to look very similar to what you've done before. We don't start getting into the interesting completable future stuff till the next couple methods. Speaking of which, the next method we're going to look at is crawl page helper. And this is a method that's going to asynchronously perform the web crawl by using several local completable future objects to download, transform, and store images on this page, as well as crawl other hyperlinks accessible via this page. As with the crawl page async method, we're going to take in the URL that we're crawling at this point and the current depth of the recursive processing. And we're going to get back a completable future to the number of images downloaded and stored. So the main difference between this method up here and this method down here is this method up here is going to do that check to see if we've exceeded the max depth or also to get the page URI by using the filter method. Whereas down here, we're actually going to do the real work to use the Completable Futures framework to do the processing asynchronously. So what will happen in this method, there's a bunch of method calls you have to make. I think there's a total of 4 of them. The first method will get a completable future to the HTML page associated with the page URI, which will then be downloaded asynchronously. And if you poke around, you'll find a method that does that. We'll talk about it in a second. You'll then call another method which will get a completable future to the number of images in this HTML page, which are downloaded, transformed, and stored asynchronously. And we'll take a look at that. The third method you'll call will get a completable future to the number of images linked from this HTML page, which will be downloaded, transformed, and stored asynchronously and recursively. And then finally, after you get those 2 completable futures, you will use them to create a new completable future that combines the sum of the 2 completable futures after they complete asynchronously. So we're going to take the 2 completable futures from steps 2 and 3 and then combine them together to create a new completable future, and that's what is going to be returned from crawl page helper. Let's take a look at the method that's used to asynchronously get the contents of an HTML page at a given page URI. So we pass it the page URI that we're crawling at this point, and we get back a completable future to the HTML page. And the way this is going to work is you're going to load the HTML page at the page URI asynchronously and return a completable future to that page. And this method should use a completable future factory method as well as a method defined on the mWebPageCrawler field. So you'll have to do a little thinking about what those methods should be. When you watch the videos about completable future, you'll see that there's a very specific factory method that you should use here that returns a completable future, and that's what you should be doing. Let's now take a look at the getImagesOnPageAsync method. And what this is used for is to asynchronously download, transfer, and store all the images in a given page that's associated with the page future parameter after it completes, after the call is triggered, when its computations are done. So we are passed a page future, which is the completable future to the page that's being downloaded. And what we get back from this method is a completable future to an integer that contains the number of images downloaded and stored on this particular page. How do you do this? Well, you're going to return a completable future to an integer containing the number of images processed on the page. And in order to accomplish that, this method should call the getImagesOnPage and processImages methods via a fluent chain of asynchronous completion stage methods. And so you'll have to watch the videos about completable futures asynchronous completion stage methods in order to see which methods to call here. Let's now take a look at the crawl hyperlinks on page async method. And this particular method asynchronously obtains a completable future to the number of images processed on pages linked from this page. And it takes a completable future to the page that's being downloaded and the current depth of the recursive processing, and it returns a completable future to an integer containing the number of images that are downloaded and stored on pages linked from this page. So the way this is going to work is it's going to return a completable future to an image containing the number of images processed on pages linked from this page, and it does this by calling a single completion stage method that calls the crawl hyperlinks on page helper method using asynchronous means. So you'll have to take a look at completion stage methods that work asynchronously to see how to do this. Let's now take a look at combine results, which combines and sums the results of the two completable future parameters passed to this method. The first parameter is images on page future, which is a count of the number of images on a page. And the second completable future parameter is a count of the number of images of all the pages linked from a page. And what we get back is a completable future to the combined and summed results of combining these two completable future parameters after they complete, after their processing is triggered. So there's a method that you'll have to know how to do this, and that's one of the methods that's defined in the completable future API. And so you'll have to learn what that one is. Let's go ahead now and take a look at crawl hyperlinks on page. And this is one of the more interesting methods here. It takes a page that contains the HTML, which is called crawler.page, and a depth of the level of traversals at this point. And it returns a completable future to an integer that will count how many images were in each hyperlink on the page once the completable future completes, of course. So here's what you do. This is kind of cool because it combines Java sequential streams and Java completable futures features. So you return a completable future to an integer that counts the number of hyperlinks accessible from this page. And it does this by using a Java sequential stream that contains several aggregate operations, namely map and collect, as well as several completable future related methods, such as then apply and futures collector int stream to future, which is defined over here in the utils directory. And there's some other helper methods you'll need, such as get page elements as string stream and crawl page async. So this will take a little bit of thinking to figure out how to connect all the different methods together into this flow. Yet another method that will be used in this implementation is called processImages, and it downloads, transforms, and stores images provided using the stream of URLs. And so you pass in a stream of URLs corresponding to the images on the page, and it returns a completable future to an integer that, when it completes, will count how many images were downloaded, transformed, and stored for all the URLs on the page. So this returns a completable future containing that count, and the method should consist of a Java sequential stream that uses the aggregate operations map, collect, and flat map, several completable future methods, including the futures collector int stream to future method, and then apply, and also various other methods such as getter download image async and transform image async. So this is going to take a little bit of thinking to figure out how all the pieces fit together, but it'll teach you some really important things about completable futures. We have yet another method called transform image async, which will process the image future passed to it as a parameter by applying all the transforms to it after the completable future is triggered when the download completes. And the way this works is you're going to return a stream of completable future integer objects to either indicate success, which will be the value 1, or failure, which will be the value 0, of the images processed by converting the transforms in the mTransforms field into a sequential stream. And this method should contain completable futures like then apply async, stream aggregate operations such as map, and a helper method, transform image. And again, this is going to take a little bit of thinking to figure out how these different pieces fit together. We then have a method here, which is actually the last method in the file, which is called transform image. And it will synchronously apply the transform to the image and store it in a cache. And so it's passed a transform, which would be something like the sepia transform or grayscale transform or the tint transform or whatnot, and an image. And what you'll do is you'll create and use a Java sequential stream as follows. You use a factory method to make a one-element stream containing just the transform, not the image, but just the transform. You'll then use an intermediate operation to try to create a new cache item for the image, filtering out the image if it's already been cached locally. You use an intermediate operation to apply the transform to the original image to produce a new transformed image, and you'll filter out any null transformed images and return the stream of filtered images, and then you'll count the number of non-null images transformed. So again, this is going to take some thinking to get the various parts right. So that is the description of the skeleton. As you can see, it's got some more moving parts than the parallel streams version, and you'll also have to do a lot more thinking because it's not just a straightforward implementation, but instead you have to understand how the asynchronous operations work and the completion stage methods work and the factory methods work and all the other types of things such as the futures collector and so on. But it's a really cool and fun assignment that will teach you a lot about how you can use completable futures to perform crawling of a recursively structured hierarchy in an asynchronous manner. Now that we've walked through the specification and skeletons, let's go ahead and run the unit tests. It's very important to run the unit tests if for no other reason that your grade is going to count almost exclusively on the scores you get from the passing of unit tests or the not passing of unit tests. So let's come down here and we're going to go ahead and right-click and run the tests. Now, also remember that tests are cumulative. As you can see here, as this is compiling and getting ready to run the tests, we have all the tests from the sequential streams assignment. We have all the tests from the parallel streams assignment, including the local tests and the remote tests. And then we also finally have the completable futures crawler tests. Now the tests are off to the races. You can see they're going and running. And surprise, surprise, all the tests pass because I wrote the code correctly. And your goal should be to have all of your tests get the little green check marks as well. And make sure that you address any issues in previous assignments where you might have failed tests before, but since then, hopefully you've come to office hours or gotten help from the discussion forums or wherever, and now your test should all pass. So if all goes well, everything should be green. And you can see there's actually a fair number of tests here, and there's 48 of them, in fact. So take a careful look at how you do, and it's especially important to make sure your tests work for the completable futures portion of this assignment because it's a lot more complicated than the parallel streams version.